Hello students, today we are going to study some concepts of thermodynamics, that is basically related to kinetic theory of gases, and we'll try to discuss some questions that has appeared in some examinations last year or even before that. So let's start discussing what we have. So I will start with one of the questions that completely is related to the concept, or say the theory of kinetic theory of gases. So let's start with that. So we have an isolated system, and I think you can go through the question and see this is basically asking for the definition of isolated system. So can you try to answer? Like I see we have students waiting, so can you try to answer this question? So let's see. The first option is isolated system is a specified region where transfer of energy and mass takes place. Second one says is a region of constant mass and only energy is okay, constant mass and only energy is allowed to close the boundaries. So this is quite two statements. One is saying that the region has access to mass, means it is open for the mass transfer, it is also open for energy transfer. B says that mass is constant, mass is not taking place from one to another, but energy has energy can pass through the system. Third one is, says is the one in which mass within the system is not necessarily constant. And option D cannot transfer either energy of mass, sorry, should be or mass, energy or mass to or from the surrounding, cannot transfer energy or mass. So what is a closed surrounding? So this is a system in which mass is able to escape and it can be added to. Same way, say this is not insulated, so some kind of heat system is able to heat it. This is one of the ways. Another, this is a closed box. You can heat it, but you cannot put anything here. The third is something isolated in such a way that nothing can go into it, whether it's energy, like if you are trying to heat it, it has been insulated in a way that heat cannot go in and cannot go out. So this is called open system, this is called closed system, and the one which is completely insulated and packed is isolated. So isolated system cannot allow energy or mass to transfer in or out. So our first answer is D. And I think yes, great. I have seen several answers D. That's great. Let's go ahead and try the next question. So this question is basically dependent on simple calculation. Let's read it out. The pressure and temperature of two different gases. I would say this is a question from already taken from some exam, but I would say the language should be slightly different. Two samples, different samples of gases is P and T, having the volume V for each. So it's basically what it is saying, that we have two samples PVT, and say this is sample 1 and another sample 2, again PVT. PVT, that means pressure is P, volume is V, and temperature is T. They are mixed. Keeping the same volume and temperature, the pressure of the mixture will be, so they are mixed such that, means there were earlier two containers of gases. The amount of one gas, or say one container, was emptied into the first one, and the temperature has been kept constant. So what would be the pressure? You can simply say the volume is remaining constant, temperature is remaining constant, number of moles. Can you say something about number of moles? Like, what do you think? Number of moles, say n, for this one is n1 and this one is n2. How could you relate n1 and n2? Would they be same? Would n1 is greater or would n2 is greater? You can see that since the pressure, temperature and volume all are same, for ideal gases n1 is equal to n2. So that means if you emptying the content of one gas's mass into another having identical volume, what you are doing, you are doubling the number of molecules or the number of moles. So what we are having earlier, we had the relationship something like, let's say it's, we are talking about the sample 1. We had PV equals to nRT. In this one also, we had PV equals to 1RT. nRT. So what will be the next situation? Means when this thing has been emptied into the first one, we don't know the P. So let's say this one is P dash. Now V is still the same. We have not changed it. This time N is 2N. We have doubled it. And RT is also the same. So if you compare this equation with this, you simply see that P by P dash, or simply P dash by P equals to 2N by N. That means our new pressure P dash is equal to 2P. You might find it easy, but there are great chances of confusing at any step. So that's why questions like this are critical. Let's try and discuss some. Okay, let's see what this question is. If the mean free path of atom is doubled, then the pressure of gas will become, okay, mean free path. So let's say, how do you write mean free path? So let's say lambda is equal to, lambda is not equal to, it has been doubled, right? Lambda is doubled. The pressure of gas will be, so if you remember the expression for lambda, it is somehow related to if you relate lambda with temperature, it is directly related to temperature, it is inversely related to pressure, it is also inversely related to the number of moles present per unit volume. So we have simply, we just need this relation here. If lambda is proportional to pressure, what will happen? Sorry, is inversely proportional to pressure and also inversely proportional to the number of molecules per unit volume. So why not make it easier? So lambda is inversely proportional to pressure. So if lambda is getting doubled, pressure will get halved. And this thing is simply that simple. We are getting pressure P by 2. Have we any answer? Great. We have the answer B. And I think we have doubts also. Why? Okay. So coming back to the last question, we have one doubt. Why have we doubled the number 2n here, the number of moles? So what is happening? We have n number here and n number of molecules, also n moles here. We have kept the volume constant, and the whole, there are two contents, n molecule and n molecule, are in the same bucket now, in the same container. So that's why uh, the total number of molecules is 2n now. I hope that doubt is cleared. So, and this one is a quick question, we just did it. So diatomic molecule has how many degrees of freedom? This is a very, very quick question. If you know the answer, you can simply answer it. And I'm waiting to see how many are trying to answer it. So, yeah. डायटोमिक के लिए अगर हम किसी भी डायटोमिक मॉलिक्यूल को कंसीडर करते हैं, say one atom, it is somehow related to this. So what is the dimension that it can move into? So obviously if it is a mass, it can move in x direction, it can move in y direction, and it can move in z or z, whatever you call it, z direction. So three are translational degrees of freedom. Then you can see that it can move along rotationally along xz plane. That means, say this is x, say this is the z plane, this is x plane, sorry, z axis, x axis, and y axis. So you can say that it can move along xz plane, it can move along xy plane as well. But what if it is along oriented on x axis? क्या इसका rotation along some other axis count होगा? Like इसका एक rotational axis ये हुआ, दूसरा rotational axis ये हुआ. So we have three translational और दो rotational. So 3 plus 2. We have 5 degrees of freedom. You might consider one another degrees of freedom, that two molecules can vibrate, and that is called vibrational degree of freedom. But we will not account that, because this is accounted only at very high temperatures, and unless it is stated in your question, you have to assume that we have to neglect a vibrational degree of freedom. So our answer is 5. Let's move on. Okay, let's read it together. A gas mixture consists of 2 moles of O2 and 4 moles of argon at temperature T. Neglecting, again you see this question has already stated it. It should be stated ideally, but if it is not, ignore it. Ignore vibrational mode. So a gas mixture consists of 2 moles of O2 and 4 moles of argon at temperature T. neglecting all bidirectional modes, the total internal energy of the system is. So internal energy U is given by number of moles into F, denoting as degrees of freedom, times RT. This is not V, this is U, or say simply say this is the energy, internal energy. So energy for O2. How many moles do we have? 2. O2 is a diatomic or monoatomic? It is a diatomic molecule. So our degrees of freedom are 5. RT, we can simply go for it. And so the internal energy for this much 2 moles of O2 would be 5 RT. Now consider argon. How many moles? 5. Let's see here. आर्गन के लिए जो इंटरनल एनर्जी है वो होगा N is 4 degrees of freedom. This is a monoatomic. We would not consider rotational degrees of freedom here. So that's why we have only 3 degrees of freedom. 4 times 3 by 2 RT again. That means 6 RT. So we have a quite easy calculation from here. 5 RT add 6 RT, we are getting a total of 11 RT. And we have a right answer here. I think someone has tried to answer it, and yes, that is correct. Someone has tried with the wrong answer, but don't worry, you just tried it. That's a good thing. 11 RT is the right answer. Move on to the next question. You might not be able to look at it clearly, as I can see. Yeah, so let's read it out. I will read it out the part where it might be blurry for you. So which of the following relations is correct for root mean square speed of a gas at temperature T? First option is VRMS, RMS, that is root mean square. So root mean square speed in option A is 3 kT by m. So let's say, let me write it out for you. First option is 3 kT by m, the whole is under root. B is 8 kT by m. C is 2 kT by m. And D is m by 3 kT. So you can already eliminate this thing because this is dimensionally incorrect. So we can say that this is a wrong answer. Now consider, let's try go the solving way, not selecting way. So which of the following relation is correct for root mean square speed? Theoretically, if you remember the formula, that's great. You can simply go for the answer. But if you don't remember, you don't need to be heartless there. You can try the derivation part. You know that the internal energy is, so at temperature T, we generally consider a gas to be diatomic because most of the gas we are encountering O2 and 2 are diatomic, and but when we are considering an ideal gas which is not written here, so if it is not written here, assume it is ideal. So for that, internal energy is equal to 3 by 2 RT or KT for one molecule, and we know that internal energy is nothing but the total energy of uh, total kinetic energy of the molecule. So that would be half mv square, and this p is obviously the average of all the, but what kind of average? That is the root mean square, RMS. So if you relate these two, you will get half m, I'm just assuming it as b, half mv square equals to 3 by 2 kt. Solving it, we can get v square equals to 3 kt by m. Taking root on the both sides, we get v equals to 3 kt by m. Do we have a right answer here? Yes, answer A is right. And yes, great work, Akash. We can keep working with me. So now, this question again has been asked in some previous examination. I don't remember which one, but let's see what it has. So a thermally insulated piston divides a container in two compartments. Volume, temperature and pressure in the right compartment. So let's try and make a diagram for this. So let's say this is our compartment, which is our container, which is divided by a piston, and this is a frictionless piston. It can move to and fro. It is also stated that this is, the piston is what is, it is insulated. The right compartment, two compartments, yeah, insulated piston divides a container in two compartments. So volume in the right part is 2V, temperature is T, and pressure is 2P. 2V, 2P, and temperature is T. But about the first part, or say left part, VT and P. Okay, VT and P. The first one, 2V. V, V, P, and T. Temperature T, volume V, and the pressure P. While in the left compartment, yeah, if the piston can slide freely, so assuming it to be frictionless, then in the final equilibrium position, the volume of right hand compartment will be, okay, so we release it from here, obviously it will go somewhere here or there, based on the pressure is here, is greater on this side, it will obviously move towards left, so it will move somewhere here. So we can deduct one of the answers, right? Obviously this one, because this part will not reduce, so this will not go below 2V, and all the answers except part A is larger than 2V, so we can strike out this one. But what about the correct answer? Let's try to figure that out. This one is a slightly difficult level, at a difficult level, but this can be answered if you are patient and analytical in your way. So let's solve it together. We know that pressure is double in this situation and volume is also doubled. Let's say the number of molecules is N1 here and N2 here. So relate this thing, PV equals to nRT, so N1 RT in the first one. In the second one, means the right compartment, we have PV, P is 2P times 2V equals to N2RT, right? Temperature is same in both, right? Okay, one thing I want to point out here, that it has not said that what will happen to the temperature. Means if something is getting compressed, obviously temperature will get affected. But in this question, when it is said that this is insulated, you should not assume that this whole system would be insulated. So assuming the temperature can be affected by the surrounding, so this the temperature of the whole system here is to be static at temperature T. So we have initial temperature T, the same will be our final temperature. So if we compare these two, say this one is equation 1 and this one is equation 2, if we compare these two, we will get that N2, what is that? N2 is equal to 4 times N1. Don't get confused. This is because if you divide this equation by this equation, we would be getting 1 by 4 equals to N1 by N2. R and T are getting cancelled. So 1 by 4 equals to N1 by N2. So N1 equals to 1 by 4 into N2, or N2 equals to 4N1. So we can simply say that the number of molecules is greater on the right side, that is 4 times of that. Now we are getting a different scenario, that this is able to move. This has been let go to move in the direction wherever the equilibrium is to be reached. So where will we reach equilibrium, and how do we decide that it will stay at some point? Something will stay at equilibrium when there is a net force on that particle or that object would be 0. And since the force acting on this is because of difference in air pressure, so if the pressure of this part and this part is getting equal, then only there will be an equilibrium. Okay, so let's say that pressure that we reach is P dash. Okay, if it has moved, then volume has also moved, or volume has decreased on this part and increased on this part. So let's say the final volume on the left part is V dash. Now, what will be the final volume on the right part? We know that the total volume is V plus 2V, that is 3V. So obviously the final volume on the right part would be 3V minus V dash. Now comparing these two and the pressure conditions, obviously if the pressure here is P dash, the pressure will be P dash here. We can simply say P dash equals to V dash. For the final condition, here the volume is V dash. We know the temperature is not changing, that is V. Sorry, T. So nR T divided by V dash equals and now we are considering the P dash pressure on the right half, means right part of the container. So this pressure is again nRT by V dash. So volume. So volume here is 3V minus V dash, and nRT, this is strictly, this part, the number of moles is not N, this is 4N. 4N RT by 3V minus V dash. Okay, so if you equate this, you can easily cancel out some terms. nRT, nRT, both are there. nRT, nRT, and we can leave one here. Again, if you go through it, you will get 3V minus V dash. Here it comes here equals 4V dash. So 2. Let's say I'm trying to write it here. 3V minus V dash equals to 4V dash. Changing side of this V dash, we get 3V equals to 4V dash plus V dash 5V dash. That means V dash is nothing but 3 by 5 V. Okay, so we found the volume on the left side, that's 3 by 5 V. What is the volume on the right side? 3V minus V dash. So 3V minus 3 by 5. That turns out to be 12 V by 5. Sorry about this congestion here. So our answer is coming out to be 3V minus V dash equals to 12V by 5. I hope this is clear to you, although it was quite being a difficult type of question. I think you have tried to answer it, and some people among you have got the right answer. Good work. Okay, we again came back to a theory, but this is not exactly a theory. We can turn it out into a numerical and try to solve in another way. So read the question with me. The graph which represents the variation of mean kinetic energy of molecules with temperature T degrees centigrade. We already know that energy is related to temperature. So it's F by 2, F being the degree of freedom, RT. So you can simply say that energy is some kind of KT. Sorry, I should not write KT because K has already some value related to R. So why don't we say K equals to some constant, suppose PT. If we graph this thing, we'll simply get this answer and we will take this answer, right? But try to consider here. It is, the unit is in centigrade, Celsius, degree Celsius. But this temperature T here is Kelvin. And when we consider the, convert this T to small t, or temperature in Celsius unit, we will be getting, so suppose it is temperature 2 degrees Celsius, we convert it to 2 plus 273 Kelvin, right? So our function would be something like E equals to P times T, T as a temperature, small t, I am writing it, sorry. T plus 273. So that's why we will not start from 0. So this would not be the right answer. Our right answer can be this, yes, but you start, if you're keeping E as say 0, temperature as 0, so we would be getting P plus something. Temperature is 0, it should be something higher than 0, but at temperature 0, energy is also 0. So this will not be the right answer. If you see this, yes, if I am saying temperature is T, temperature is 0, it will have some 273 P, that means greater than 0 value, this here. So that's why this could be the right answer. This is a curve. Obviously this will not be the right answer because we are supposed to get a linear function here. So obviously option C is the right answer. Let's move on to the next question. And yes, someone was trying here. Okay, let's try and read this next question. Gas at a pressure P0 is contained in a vessel. If the masses of all the molecules are halved and their speeds doubled, then the resulting pressure will be equal to. Okay, so that means we are considering the masses and the speed of all the, so how can we relate masses and the speed of molecules with pressure? Are they related? They are, but the relationship a little bit complex. We know that the uh, molecules collide with each other and with the walls of the container, and that's how they create pressure, and that create a force on them, and the force per unit area is the pressure. But how can we relate that? One way is this. If you consider a gas sample, say it's a monoatomic gas sample at pressure P and velocity V, what would be the energy? Energy is 3 by 2 kT or 3 by 2 RT for a 1 mole. But in terms of P and V, we can say that it's simply 3 by 2 PV. Now, if we write this thing as a in form of the sum of kinetic energy of all the molecules, we would say half m1 v1 square plus m2 v2 square plus adding so on to m n v n square. What is n, capital N? That is the number of molecules present. Means we are considering that n number of molecules, n number of gaseous molecules are present in the container, and we are summing up the kinetic energy of all these. We know that masses m1, m2, mn are same, so we can say half m into v1, v2, v and so on. So it already says that all the molecules are halved. masses are halved. So what has been done? Mass has been halved. We can simply say that this is equal to mass and the root mean square of the velocity. Square of the root mean square velocity. So if mass is halved and this one is doubled, so what we are getting? Once it is getting halved times 2 square. So that is the fraction that we are getting is 4 by 2, means the whole thing is getting doubled. So energy will get doubled. Now we know that energy is getting doubled and volume is constant, because volume has not been mentioned here. We are considering that to be constant. So if energy is doubled, means I would not write that this way. If E1, 2E1 equals to T2E2, so we know that 2 times PV, also 3 by 2 of PV, 2 times 3 by 2 of PV is equal to 3 by 2 of nu P, that is P dash, times V. V is, this is the capital V, volume. So comparing this, we would be getting 2P equals to P dash. So our new pressure is double of the initial pressure, that is 2P naught. And am I getting the right answer? So moving to the next question quickly. For a gas, the RMS speed at 800 Kelvin is 4 times the value of 200 Kelvin, half the value of 200 Kelvin, twice the value of 200 Kelvin, same as the value as 200 Kelvin. So you can strike off these two options, because obviously if the temperature is increasing, the RMS speed will also be increasing. But we know that temperature is directly related to the square of RMS. So if the new temperature is 1/4, that means T dash equals to T by 4, then corresponding VRMS, V dash square would be 1/4 of the old VRMS. So that gives V dash as half of old, means initial VRMS. So that would be twice the value of 2K. Means obviously the new one is half, so the old one is doubled of that. So this is our right answer. So that concludes our session today. It was completely about kinetic theory of gases and thermodynamics. You may find more challenging question, you might find some easier question, but basically this was the level that you find there. We will definitely consider your comments that you put here, and we'll keep on improvising on that. For now, it's time to wrap up the session. I'll say goodbye to you. Keep prepared. We'll meet again in the next session. Thank you.